Welcome to the third edition of Python Ireland Remote Meetup. Thank you very much for you that is here with us. Thank you for joining. So the plan for tonight is we have two awesome speakers here with us tonight. So welcome, Isaac. Isaac Evans with Good to the Last Drop, writing robust Flask and Django apps. And then we're going to have a short Q&A session. And after that, at 8 p.m., we start our second talk with Stephen Finucane, a documentation-driven approach to building APIs using Django REST Framework and OpenAPI. And then after that, we have our lightning talks. So if you have any lightning talks, if you'd like to submit a lightning talk to us, just follow a link. I have a link on the Meetup page, but I can also post the link here in the chat. And then after that, if we have nothing else to talk about, we're closing for today. Perfect. So with the Did You Know session today, I decided to talk about Audrey Tang. She's been described as one of the best Taiwanese computer personalities of this century. She is an expert in Perl, and she wrote the first implementation of Perl 6 using Rascal. It's actually quite interesting how she decided to use Rascal to do that, because she's an expert in Perl, and how the whole how the entire team came together to actually develop that implementation of Perl 6 is quite interesting. In 2016, she became the first transgender minister in Taiwan. So that's quite something as well. And her TEDx video on digital social innovation to empower democracy is very, very cool. So if you guys have a little bit of a, let's say, anarchist side on you, or if you'd like to know a little bit more about her YouTube talks are actually really, really good. Then let's go for our announcements. So the Python Software Foundation is looking for product managers to help with CPython's migration to GitHub. They just moved from Bugs, I think the name of the old website is Bugs, and they're looking for people to help with all the issues migration. So if you're a project manager and you'd like to help with that project, then you should just have a look at their website and, well, send your resume until the 4th of June, and best of luck. EuroPython, we have more news about EuroPython. So they are hosting there's a new track. There's probably going to be a new track for speakers on the other side of the world, and we're looking for speakers. We're looking for proposals for that. So if you missed on the first call and if you missed on the second call, now it's your chance to submit your proposal. I have a chat message over here. Just 1 second. Then, oops, sorry, technical issues. Then I think it's time then to start. I'm going to give the stage to Isaac Evans, and we're going to talk about Flask and Django apps, how to build robust applications.
All right, well, thank you so much. It would be amazing to be in person in Ireland, but I am here in San Francisco, still under quarantine, probably very similar to you all. And today, this is Good to the Last Drop, writing robust Flask applications. Is the full screen working?
Yes.
Confirm that? Awesome. Cool. And just for context, this presentation is actually something that we were planning to give at PyCon this year, but unfortunately, as you may know, PyCon has been canceled, but this was accepted. So what we're presenting is a little bit of a modified version, a little bit shorter for the Meetup format. But to start off with, I guess my first thing I'd like to share is, why is it important to write robust Flask apps in the first place? And I guess I have a little bit of unique perspective here because I used to work for the US Defense Department on essentially what was a large criminal organization legitimized by law. And my message is that the sad news is it's a lot of fun to be a criminal. And unfortunately for you, if you're trying to deploy a web app, there are people who are going to have a great time breaking into it and doing all sorts of fun exploitative things. So I have this perspective of having been on that side of it, which is kind of interesting. And today I'd just like to share with you a little bit more from a kind of attacker's perspective, the things that I think are really valuable for making something robust. So this is me. I'm one of the co-founders at a small startup named R2C. We have a bunch of other team members. So all the work that I'm going to be presenting today is really the work of a much, much larger team. And our work is really about trying to automate security for developers. So releasing open source tools and providing commercial services for large companies on top of them. So I'm going to give you the TLDR, the too long did not read or too long did not watch in this case for this talk right up front. There's a Flask security considerations, which is part of the documentation for Flask. If you haven't read that and an attacker has, you're always going to have a bad time. So that's going to be one of the #1 recommendations. And then favoring things that are secure by default frameworks and architectures is one of the highest, return on investment things that you can do. We're going to talk about a couple of those specifically in the Flask context. And then the last thing that we're going to talk about is tools that we can use to check code with code. So automating a lot of the security recommendations and advice. So we're going to be using a tool that was originally open sourced at Facebook and that R2C, my company, now maintains. It's open source. It's called the SymGrep. It's basically a grep that's aware of code structures. So we're going to actually use that to live probe through some code and build some queries that will automatically find stuff throughout the talk. And this is going to be a lot of information. So the point of this talk is to educate. In reality, you really don't want to have to be an expert. You want to, as much as possible, automate things so that it's a foolproof and no thought required process. But to get there, you need to start to understand sort of the background of things. So in case it's been a while, or maybe you've never even written a Flask application in the first place, this is the most basic app.py we can imagine. So we import Flask, we initialize this app. We have a decorator that we're using to say, okay, when somebody requests the homepage / we're just going to return hello world, and then we call app.run. We're going to use this example as the basis for all of the code snippets throughout the presentation. So I'm just kind of putting it out here as a refresher. And if you wanted to copy this down, you can find this on the Flask tutorial pages and whatnot. So our real question is, if we're going to go run Python app.py, our little Flask application, and we put it on a web server and we exposed it to the entire internet, how do we know if that's secure? So there's 4 parts to what we're going to do to understand that. The first part is understanding the stack. When we run Python app.py, there's a lot that's going on underneath the scenes, behind the scenes. So which parts of that actually matter to us? The second thing is we're going to try to understand, okay, how could we possibly be vulnerable? What are the ways in which somebody could attack us? And for that, we're going to use a specific framework that gives us an ontology of vulnerabilities. The third part, which is going to be fairly straightforward and a little shorter, is we're going to talk a little bit about how you assess risk as probability by impact. And then the last part, we're going to talk about tools that you can use to automatically check for security and correctness bugs in your code. So the first bit, understanding the stack, and feel free to interrupt me with questions in the chat. One caveat is, well, let me see. I think I can actually pull up the chat while it's going. Yes, okay, I can see the questions now. If you put them in the Zoom chat, I'm not watching the Twitch or YouTube chats, so those will have to be relayed. So the good news when we think about the stack is that we're using Python. So we're actually immune to a whole bunch of attacks. Like if we were writing C or C++ code, we would have all these heap or buffer overflow type attacks, which would lead to what's called stack smashing, where basically it's not our program anymore, it's the attacker's program, and somebody around the world could have remote control of our computer. Additionally, most kinds of memory disclosures, like the heartbleed bug, for instance, which is illustrated by this XKCD comic on the right, we should be immune to that because we're using Python, which is great. So all these nasty attacks that you've heard about, probably totally immune, but there are a couple caveats. So one thing that you might know if you've ever dealt with a big machine learning framework is that it's still possible to have memory leaks, even though Python is a memory safe language. So it's possible for there to be a bug where your Python program just keeps allocating gigabytes and gigabytes of memory and eventually runs out of memory. And it's possible for an attacker to trigger that bug if it exists. Additionally, just because you are writing a Python program doesn't mean that what is underneath is actually Python. So for instance, if you've ever used NumPy, the numerical computation library for Python, NumPy is actually mostly written in C. And because it's written in C, it can have all of these same classical attacks, buffer overflows and things, even though you're using it from Python. So an easy example of this, if you've ever used numpy.empty, which gives you back an empty pre-allocated array, that's actually returning uninitialized memory. So technically, if you tried really hard to shoot yourself in the foot, you could have a heartbleed type situation if you are returning in your Flask response the allocation from numpy.empty. But broadly speaking, I've got a really simplified view of the stack here. We've got our app.py, which we wrote. Beneath that, we've got the built-in or third-party libraries. So this is where libs like Flask or Django come in. And then, of course, we have to pick a specific program to run Python. Python is just a language. We need an actual program that knows how to load Python code and execute it. So if you've acquired Python through the normal ways, you're using an interpreter called CPython, which, as the name suggests, is written in C. And then that is going to link to libc, which is the C standard library on your operating system. Or if you're using Alpine Linux, it'll be Muscle. If you're using Windows, it'll be the CRT. And then beneath that, you have the operating system. So the great news here is that really all these bottom 4 layers are somebody else's responsibility. And your job is to stay up to date. So you might think that there aren't security problems being found very often in these layers, but in fact, you'd be wrong. They're found all the time. Here's a list on the right of a bunch of the security vulnerabilities that have been found just in the top 2 of those red layers. Actually, our company, one of the team members that we have, found one of the vulnerabilities in January of 2020, a high severity vulnerability inside the Python core, which was super cool. So the takeaway here is that you have to stay up to date, which means that unfortunately, you are in the same dilemma as everybody else who has to update software, right? You can try to spend the rest of your natural life trying to figure out how to upgrade it, or you can be completely screwed and owned by people who are just exploiting a known vulnerability deep down inside your stack. So I have some more specific recommendations than just stay up to date. I would highly recommend using pipenv or Poetry, which make it much easier to update your dependencies. So if you've ever worked on a bigger project, you've probably had a requirements.txt file, which specifies, oh, go pip install this package, and then pip install this package, and maybe it'll even specify some of the versions. It turns out there's actually a new version of requirements.txt, which is called the pip file, and there's a pipfile.lock. And these are great for security because they actually specify not just I'm using this dependency, but the exact version and the content hash of that dependency. And it will do that all the way out through the dependency's children and their grandchildren, et cetera, to the bottom of the dependency tree. So it's actually great for security because it means that if you installed this on your machine and you ask somebody else to install it on their machine, if they have this pipfile.lock, they're going to get the exact same, hashes will match and everything version of your dependencies, which is really helpful. And then pipenv and Poetry just help you manage that file. Both of them have an update command, which will automatically just update all of your dependencies to the latest version. So that's great. Definitely check those out if you haven't heard of them. Pipenv has been around. It's a little bit more established. Poetry is a little bit newer. It's not as popular yet, but it's maybe a bit friendlier on the command line interface, in my opinion. And then, of course, there's Python, the Python interpreter. So one of the things that I do is I just subscribe to releases for that on GitHub. There's probably some mailing lists and things that you can find, although I haven't found a just security releases mailing list for CPython, unfortunately. And then, general advice applies about, oh yeah, you got to keep your operating system up to date because that can have vulnerabilities that can affect you. And if all of this seems a little bit overwhelming, there are some subscription services that will give you a feed of updates if you need prioritization. GitHub has that built in now. There's snyk.io, pyup.io. I'm not affiliated with any of these folks, but I think they do a pretty good job of providing some levels of prioritization. Any questions on the sort of update recommendations or advice that other people have? Feel free to drop it in the comments, and I will pick it up later. So now we come to the other part of the stack, app.py, and those built-in or third-party libraries. Your app and the interaction between it and those libraries is your responsibility to get right. So that's going to take us into the second part of the presentation. For the part that we care about, that we're responsible for writing, what are the possible ways by which we can be attacked? What kind of vulnerabilities can my web app possibly have? Well, fortunately, there are a couple different taxonomies that folks have created with just a bunch of different sort of lists of, yeah, these are all the ways over the past 50 years that we've seen applications get attacked. The one that we're going to use today is by the Open Web Application Security Project, which is a long name, so I'm going to just refer to it as OWASP. It's called the OWASP Top 10, and it's actually based on, empirically, this is how we see people getting hacked. And so we've prioritized, like here's the number one way, the number one thing on that list is the number one way that people are getting hacked in their web applications. But just, like this is kind of overwhelming. If you get into something like MITRE's CWE framework, which is very extensive, there are literally hundreds of things. So what I encourage you to remember is that, this is sort of my security philosophy. A short wall is better than a tall gatehouse. It's better to have a very short fence that actually goes around everything than the photo here on the right. And simple is better than complicated, right? This is a way in which the security world sort of intersects with the Python world. When done right, Python is simple and security should be simple as well. I noticed there was a question in the chat about how is pipenv different than normal pip. Pipenv is a wrapper around virtual env and pip that manages, so it manages the dependency lock files for you. And then it also lets you just, it's much more convenient to create a virtual env from the requirements.txt or from the pip file. So it's not like strictly different than normal pip. It's still using it underneath, but it's a wrapper around it in virtual env. I think it just makes it so much easier to use. So thanks, Navankar, for the question. Great. So without further ado, we're now going to start talking about, let's see what's on this OWASP top 10 list. So here are the top 10 from OWASP. We're not going to have time to talk about all of these today, even with an hour. So I'm just going to focus on 5 of them: injection, XML XXE, security misconfiguration, cross-site scripting, and insecure deserialization. I've tried to pick the ones that might be a little less obvious to somebody who's looking at this list for the first time. If you see like broken authentication or sensitive data exposure, you might have more of an idea of what that is versus XML XXE. So let's get started. Even under the top category, injection, there are many different kinds of injection. So we're just going to talk about 3 today. Actually, just yesterday, we co-published with Jacob Kaplan-Moss, who's one of the creators of Django, a blog post about how to prevent SQL injection. Because incredibly, after 10 years that OWASP has been maintaining this list, this is still the #1 item and way that people get hacked. So here's an example of like we've just added a function to our app.py search. It's taking in a request. We're getting the query from the user. We're putting that into this SQL string that we're sending to the database. So if you've heard about SQL injection before, you're probably like, okay, I know where this is going. But if you haven't, or even if you'd have, I'd call your attention to the fact that this looks really innocent. This is the exact sort of thing that you would see on Stack Overflow as an example code snippet, or in like a book that you might be reading about how to get started for the first time. And it's that sort of doing the wrong thing does not look like the wrong thing that I think makes this really insidious. So I'll give you a few more seconds to scan the code. Feel free to drop in the chat if you think you've identified the problem. I'm going to take a quick sip of water, and then I'll get into what it is. All right. So, like I said, if you've seen this sort of thing before, you know exactly where this is going. But what if Q, which comes from the user's browser, looks like this: apostrophe space or space 1 = 1. Well, if that's what Q is, then the database is going to see something that looks like this. And in case you're not super familiar with SQL, this last bit here, like empty string or 1 equals 1, is going to always evaluate to true. So now, instead of actually honoring the parameter that came from the user, we're going to return everything in this table in the response to the user. And this can be really bad if everything that's in the table, for instance, if this is like the users table, suddenly you can use this to dump the list of all of the users along with their passwords. Hopefully those passwords are hashed. And you know, this is something that unfortunately is just a gotcha, right? Like it looks really, really simple. It looks very straightforward. And if you did this in a web application, you would be hacked, no problem. So what are the recommendations? How can we get ourselves away from, you know, like we don't want to have to train every single developer necessarily about don't do this. Like, yes, we should do that, but is there anything else that we can do? Well, the first thing actually is just don't use SQL. You know, which maybe if you've been writing a lot of like SQL scripting applications, that sounds crazy, but most web applications will actually use an object relational mapper. So, you know, instead of fetching the users from the users table with a SQL query that you have to write yourself, you'll just have a user class and you can say user.get. And underneath, there are some exceptions, but by and large, the SQL you know, databases don't have this problem of, the object relational mappers will take you out of this world of having to worry about sanitizing SQL inputs. The second thing you can do, which, you know, if you've heard about this before, it may be what you expected to be my #1 recommendation, is to sanitize user input. So use a function that is going to strip out apostrophes and other things from that query object. To be honest, you know, even though this used to be the thing that people would say, I think that it's fairly bad advice. And the main reason why is it's hard to remember to do it everywhere. You know, every flow that comes from the user that goes into the database, you have to properly sanitize. And then actually, even if you do it everywhere, if somebody changes the version of the database or the type of the database on the other side, your sanitization function might not actually be stripping all of the bad characters again, which sounds crazy, but can definitely happen. So this has a lot of pitfalls and it's a lot of work. Actually, the ideal solution is to maintain separation between code and data, to use parameterized queries. So, you know, what's unfortunate here is that this query, I think, looks really similar to the query that we just saw, but underneath the difference couldn't be more dramatic. So what's going on in this example, example number 3 here, is that the separation between the code and the data, the separation between the SQL query and the data for that query is maintained all the way to the database. It's basically like the query is going in one packet to the database, and then the user data is going in another packet to the database. So this is definitely what you should be doing. You should be using parameterized queries. You shouldn't be concatenating strings together to send data and queries to the database. And then the next thing that you want to do is really try to prevent merges to master that sidestep any of the above, right? So we've actually written some queries. I'll show you an example of this later, but well, you can come back to it in the slides. I have a query here that will detect anywhere where you're using SQL Alchemy and you're using raw SQL and you're not using one of the parameterized queries, which is super cool. So the next kind of injection is template injection. So this is something that's unique to Flask. So we've got our little app here. We've added a new route, my route. It's an error handling function. And we've got this render template string function because we had the template just embedded as a string that we're creating inside our application rather than making it a standalone HTML file. And so I'll give you a minute here to just kind of parse this and see if you can spot what the problem is specifically. So I'm going to highlight it. This works. Yep, there we go. Great. So this is actually an interplay between a couple different things. Basically, we're trying to inject the referrer, which is sent by the browser, into this template file, and we're using this render template string function to do it. So what could possibly go wrong with that? Well, if the referrer that is sent by the user's browser, which is totally underneath their control, is something like this, curly brace, 7 times 7, curly brace, then it's going to render as 49 in what the server sends back. So that might seem kind of harmless, but consider what would happen if the user put config inside that refer value. Well, then our server would just put whatever the contents of the config dictionary is directly into the page and serve that to the user. This could be really, really bad if we have any kind of sensitive information like our database password or secret keys or things like that inside our configuration, which if we're running a production web app, we almost certainly do. And this is one that I think is, it's subtle and it's unique to Flask. So the recommendation here is don't use render template string. Instead, use the much safer render template method. And then really just prevent merges to master with this render template string because it has too much power, essentially. You don't want to be evaluating arbitrary variables that came from the user inside these templates. So I'll show you a quick example of what this would look like. And I'm just going to copy and paste this thing from the more complicated version to a simpler version. I've got a little snippet of Flask code. It's actually exactly what we were just looking at. And this is just a live editor for the tool that I mentioned at the start called SymGrep. So you don't have to run this online. You can run it with Docker locally. The tool is open source. So if you go to the GitHub repo, you can install this with Brew or on Ubuntu. And then you can actually run this little snippet. You can see we have a short URL on your own code, which will run totally offline. If you wanted, you could compile and build it yourself from source as well if you wanted to verify that. So that's how you run it locally, but I'm just going to use as an example up here. So I've grabbed this thing here, Flask render template string. I just want to detect anytime somebody in our code base is calling Flask render template string. So to do that, I can just grab like this line of code from down below and copy and paste that up here. I'm actually just going to put a ... there because I don't really care about what's going on inside. And then if I click run, it'll identify, it had already identified because I loaded it, this little snippet here. So one of the other things we're going to talk about is like what's different between this and regular grep, because I could also just write a grep expression for this. But one of the cool things is, like imagine I've said import Flask as f, for instance. And so then this would be not flask.renderTemplate string, but f.renderTemplate string. Well, in that case, this query is actually still going to find it just fine because it's not just based on the literal text. Like it's actually parsing the code here. So even if we have wonky syntax, like we put this on a new line or we added a bunch of white space, it's still going to find it for us just fine, which is pretty nifty. So we'll come back to that later because we've actually written a bunch of different queries for the specific recommendations that we have in this presentation that are available for you to use totally for free. Cool. So the last kind of injection we're going to talk about is CSV injection. So this one is a little bit more obscure. You may not have heard of it before, but I'm going to use it to kind of illustrate just how big of a generic problem injection is. So here we've got this route. It's fetching some user data, which lives in a CSV file. We get the file name for the user's preferences. We open that, and then we just return it as a CSV. So again, like this is one of those gotchas where if you know what the attack vector is here, you're like, ah, yes, I can see what's going on. And if not, you're like, well, I've probably written some code like this. This looks totally fine. And in fact, the subtle thing here is what if that user data, has some fields, let's imagine like name, date of birth, address, and since the user is allowed to fill out those fields, they filled out name John Doe, date of birth, and then their address is kind of strange, equals command pipe apostrophe space /c. If you open this in Excel or OpenOffice, you'll get a message that pops up kind of like this. It'll say, hey, Office has identified a potential security concern. Your computer may no longer be secure. Don't enable this content unless you trust the source of this file. But let's think about where this file came from. Well, the user just downloaded it from your website. So, presumably they trust your website. It's not like they downloaded it from an email or some random third-party website. So honestly, they're going to be more inclined to click enable than anything else. And what this command is going to do, this syntax in Excel, if you click enable, it will just run any arbitrary command on the user's computer. So in this case, it's just going to pop open a calculator, but it could also be used to send all of their files to an attacker's computer or something like that. So that's just great. And the fix for this is to escape data that flows into a CSV using either single or double quotes. That will prevent this in most in all these CSV processors like Excel and OpenOffice that I know. But the bigger piece, and we'll come back to this, is to understand the threat model. Is this a way you have to know something about the users of your application and your responsibilities, right? Like if you're creating data and passing it off to your users, are they going to trust that data? Are they going to understand the implications of opening it in other programs? So for a lot of you, like this might not be something that you care about at all. And for others, like this might be a really clever way that somebody can eventually hack you. So we've covered injection. We didn't cover all of it, of course, but the central lesson here is, hey, anytime you kind of mix something that should be data, like in that example, that should have been an address, and instead it became an executable command, you're going to have a bad time. And so as much as possible, maintaining separation between code and data is a right way to fix these sort of injection problems. Now we're going to talk about the fourth thing on the OWASP list, which is XML external entity expansion. So I'm going to give you a second to look at this XML file. If it's been a while since you've seen XML and you've been able to skip it, I apologize. Your first reaction might be, oh, the problem here is, there are some languages that are meant to be read by humans, not by machines, others that can be read by machines and not by humans. And XML solves this problem by being readable to neither. You would be correct, but there is in fact a more subtle vulnerability and obnoxious problem going on inside this. It has to do with this line, the second line from the bottom, where we've got file : etc password. And it turns out that XML has a feature called external entity expansion that will basically, if you load up this XML file, it will just put the contents of whatever was specified here, it'll inject them into the XML file. So if you are, if you're letting a user upload an XML file and then you're opening that XML file and then serving it back to the user, since it was loaded on your system, the contents of any arbitrary file on your server can be suddenly displayed to the user in this XML file. So this is subtle, and if you deal with any kind of XML input that you don't totally trust, you're going to have a bad time with this. Turns out there's actually a whole bunch of different attacks on XML. And unfortunately, if you're using Python 2, there are 5 libraries for dealing with XML inside Python, and most of them are vulnerable in Python 2. In Python 3, they fixed most of the worst vulnerabilities. So like if they're now safe from XXE in Python 3, which is the matrix on the right, but they still have a bunch of denial of service attacks where basically somebody can send you a tiny XML file, which can suddenly grind your server to a halt because it takes so much processing power or memory to open that XML file. The recommendations here are don't use XML if you can help it, but if you're having to use it, it's probably not an option. The second recommendation, which would be very sensible, would be, hey, don't use XXE support in your library, just turn that off. But unfortunately, there's no option, as far as I've been able to find, to disable that support in the Python XML parsing libraries. So actually the number one recommendation, which if you read the Python documentation, they actually explicitly recommend, is to just use a different library. So there's a library with a great name, diffused XML, that you can use, which is not vulnerable to any of the attacks that I listed in the matrix on the previous slide. And again, use a tool like grep, or here's an example of us using symgrep. So I've got a pattern. One of the cool things here is that we can actually specify a fix as well. So I can say, oh, instead of import XML, import diffused XML. And then that will, like if I run it on the code base, I can actually, this is in the live editor. If you're running it on the command line, there's a -- autofix option that you can provide as an argument here. But I can just come in and say, oh, apply fix. And boom, I've transformed this code for myself or for the pull request, where my coworker was maybe committing that example. Great. So that was a whirlwind overview of XML XXE. XML is kind of a dark space. There's just a lot of lurking security vulnerabilities that matrix talked about. The next one we're going to talk about is the 6th thing on the OWASP list, and it is security misconfiguration. So I personally love this one because I think it is one of the best bang for your buck when it comes to, oh, in a single line of code, you can have a vulnerability that makes you get totally owned. So here we've got a modified version of our Flask application. Feel free to chat off in the comments. There is at least one problem in this example. And I'll let you have a second to do that while I take another sip of water here. All right, super. So the first thing that you might have been drawn to was the fact that the secret key is hard-coded to be this development key, which is not great. Ideally, this would be something that comes from an environment variable. Is actually a very long random value. But it turns out that Flask has a unique problem with this debug flag. So if you're writing a Flask app with the debug flag set equal to true, Flask uses a debugger by default that, when is enabled, if your application throws an exception, it will actually pop open a terminal that will let somebody just inject arbitrary Python code into your application. So like if basically, it's a great feature for debugging because you can just be right there. It's like you've got a debugger in the Python code and you can just run more Python code. But this is a super easy way to get hacked. And in fact, this is believed to be the way that Patreon, which is a startup out in San Francisco here, got hacked back in 2015, was that they had this Vertcoig debugger, which is the built-in debugger for Flask, publicly exposed just from that one line of code, that app.debug equals true. Now, the good news is in the very latest versions of Flask, they've added a PIN number to this thing, but still the security is not great. And you're just asking for trouble if you are running this thing in debug mode in production. We're going to come back to this later because this is a great example of a gotcha that the framework designers really ought to have gotten rid of. And we'll talk about that when we talk about secure frameworks. The other reason that I like this from an attacker perspective is that there's no easy fix to security misconfiguration. You know, fundamentally, you have to read the documentation for your framework, and you have to pay a lot of attention to the notes. So like, here's an example from the Python 3.7 docs of just like a little note. It's like, you know, if you're using this thing, hey, this might be a security risk, but it's pretty subtle. One of the things that a lot of people do is they'll use the code owners file, which is something that's supported on both GitHub and GitLab and a lot of other systems. That basically lets you say, hey, if anybody, you know, if this person touches this file, then I want person A or person B to be a mandatory reviewer for that file. So if you've got somebody who's an expert on Flask in your organization, which maybe you're that person after today, you can put yourself in the code owners file. So like if somebody's changing the configuration.py or something like that, you are marked as a reviewer on any important change sets. And then of course, you know, automate finding these issues as much as possible. I'll show you at the end of this, this registry that we have, which has a bunch of checks for Python Flask. So the seventh one on the OWASP list is cross-site scripting. And this is another one that is just really pervasive problem. So here's an example. I'll give you a minute to look at it. I think the interesting thing, if you're already familiar with cross-site scripting, or XSS as it's commonly known, is that there's actually one vulnerability here, not two. So I'll give you a second to take a look at what the problem is. The problem here is what if the contents of value are on mouse over equals alert XSS plus document.cookie. Turns out that there's a really easy ways for, well, this example actually got a little bit screwed up. Value should be an attribute on LI in this part of the presentation. I apologize for that. Somebody was tweaking with the slides right before I gave it. That's all right. So just imagine that this this bracket got moved down to the next line. So then value is not something inside; it's actually an attribute on the list item. Well, the weird thing is that this little snippet of JavaScript will execute just fine if that's true, but it won't execute in the context of something like app name. And so if we go and look at the Flask documentation, the good news, so this is good, definitely good. Flask configures Jinja 2 to automatically escape all values unless explicitly told otherwise. But there are still some places where you have to be careful. So attributes, for instance, HTML attributes will not get quoting by default. So here we have yet another gotcha. In fact, there are a lot of gotchas when it comes to cross-site scripting. And I think this is one of the areas where Flask does the worst in trying to help people out of this. So another interesting little example is that if you are using a template that ends in .html, .htm, .xml, or .xhtml, the escaping is turned on. but if you use any other file name, it suddenly gets turned off. So we already saw the like auto escaping differences between render template string and render template. And there are a couple different other ways that you can escape out of the protections that Flask gives you here. So just to make that really concrete, if we're using render template with safe.html and we're like putting in something that came directly from the user, so the arguments, the hello arguments here, this is safe. So rather than executing this code, it's just being displayed. That's exactly what we want. We want it to be displayed. We don't want it to be executed. But if we are rendering unsafe.txt or unsafe.html2, for instance, boom, all of a sudden the autoscaping is turned off. And now we're running arbitrary code from the attacker in the context of the user's browser, which is really not great. So the quick summary of the gotchas here is that definitely make sure your template files have the .html extension. You have to do special quoting on HTML attributes. And if you're using template variables, for example, for hrefs and anchor tags would be the most obvious example of that. That's unsafe. And there's the comment in the chat that's like, oh, you're not selling Flask variable right now. Believe me, Django has problems like this too. All of the web frameworks have problems that are similar to this, which is why XSS has just really been kind of a scourge and a source of so many vulnerabilities. So the one recommendation that you'll hear a lot with XSS is to use a content security policy. So this is actually a super powerful tool that because, basically because people who were running websites were doing such a bad job preventing XSS, Mozilla and Chrome and Internet Explorer were like, guys, we should put together something in the browser that can just help stop XSS vulnerabilities because they are all over. So in fact, every large website you go to, like if you go to Facebook or any Google or Twitter website, they're all using the content security policy as a kind of fail-safe to try to make sure like, oh, even if we did screw up, we're using the CSP to like block these sorts of attacks. We're not going to have time. We're running a little bit short on time. I mentioned this was originally a PyCon talk and was a good deal longer. So I'm going to skip over some of the details about content security policies, but the slides have been posted. So feel free to, we can talk about this in the Q&A, or you can go back and just look at the slides, but there's a lot of detail there. And I'm just going to jump right to the recommendations about XSS. So actually, to be honest, my #1 recommendation here is use a framework that is less vulnerable to XSS. And the one that I would specifically call out as having done a good job is React.js, which came out of Facebook. So I'm not here to get into a religious argument about like which front-end framework is better. But I do know that one of the design goals for React at Facebook was to reduce the number of XSS vulnerabilities that Facebook was having. And it turns out that React is actually subtly but very importantly different than many of the other frameworks like Angular and Vue. It's very ahead. We'll talk about this a little bit later when we talk about secure frameworks and making it harder to have XSS. Some of the other recommendations that we already talked about, use an HTML extension for templates. We actually have a SymGrep check for that. Setting the content security policy for your application. We've got one of those too. And then there's a cool framework from Google, which is open source, called Flask Talisman. And Flask Talisman automatically enables a sensible content security policy, as well as a bunch of other things that we haven't even had time to talk about, like hardening your cookies and things like that. And it's pretty easy to set up. Like I've actually got a little example of exactly how you do it. You just wrap your Flask invocation in this Talisman thing. But whatever you pick here, like you really, again, you want it to be automatically enforced. So I promise we're getting to the good news where there is hope to be able to automate some of the stuff rather than having to just know it and keep it in your head. So we finally reached the last OWASP vulnerability that we're going to be talking about, which is insecure deserialization. If you're not familiar with the pickle library for Python, pickle lets you basically take a Python object and save it to disk and then load it back from disk. So it's super useful. In this case, in our web app, we're using it to store some preferences from the user, which probably looked like a dictionary. We'll load it from this .prefs file. And then when we get it from the user, we'll save it to that prefs file. So again, like there's nothing here that when we look at the code, unless we have some domain-specific knowledge, looks wrong or off. But it turns out there's a pretty serious problem. So if the user is able to make like one of the inputs to those user preferences, which again, like this is probably, they're just putting into a web form, hey, these are my preferences. If they put in something magical like this, this is actually a full exploit chain. So it will connect back to evilserver.com and give the owner of evilserver.com. It will be as if they've SSH'd into your web server, which let's take a moment to appreciate how awesome that is. And how would somebody even come up with this sort of invocation in the first place? Well, it turns out this vulnerability for that pickle module is actually so frequent that there's a specific payload generator for a hacking tool called Metasploit, which will just generate a payload that you can dump into these, like any kind of input to the pickle functions. And unfortunately, this is a problem for many other formats. For instance, PyYAML would actually do the same thing. And I think they finally fixed it inside the most recent version. But there's a YAML.load function, which if you're loading untrusted user input, it will just execute arbitrary code. You have to use this YAML.safe_load instead. So this is unfortunate, right? It's kind of pervasive. It's so convenient and easy to use. You can easily see yourself or somebody else being like, oh yeah, like I'll just load that YAML from the user, or oh, I'll just save this user data and then load it back up. But in fact, I mean, that's why this is on the top 10 list. So I'll just pause to check the chat for questions real quick. All right, I just checked the chat real quick. I'm not able to see the Twitch, so feel free to interrupt me, fellow organizers, if there's any questions there. There was some commentary about the YouTube thing not working. Apparently, there's a banned. The presentation has been banned from YouTube. I promise it's not something I said. I think it's just because in the description there was a mention of Twitch, another streaming platform, which is apparently enough to trigger a ban. So great, we finally got through the OWASP top 10 for web applications. Unfortunately, like maybe you've been sitting through this whole the presentation and you've been like, this is silly. I don't have any, like I'm just here using Flask or Django for an API. I just take JSON in or take JSON out. Like we don't do any HTML nonsense here. OWASP has you covered. They have another top 10 specifically for APIs. There's some great stuff in there. For the sake of time, we're not going to have a chance to cover it, unfortunately. But the stuff that you should look out for are mass assignment and CSRF in Flask specifically, as well as open redirects, if you're digging through that. So what we've learned so far is basically that security is just full of gotchas. All over the place, there are these sharp edges that we just keep getting bitten by, and it seems like it's an impossible task to really keep on top of all of the different ways that we can get exploited. And so at this point, you might be tempted to just kind of throw in the towel altogether on security. But that's why we have the final part of the presentation. So good news. The first thing is, like some of these things you just don't have to care about probably. So if you hired a professional security person to come in, they would have you build a matrix like this. And in that matrix, they would basically say, okay, what's the probability that like this is going to be a problem? And then what's the impact if it's actually exploited? So the critical things that you absolutely have to fix are, this is high probability and extremely high impact. But a lot of things, like the CSV example, it's like, well, maybe it's moderate impact to us if one of our users is dumb enough to click that enable button, but it's pretty unlikely, so it's low severity. The comment that I'll make here is that, I've given a bunch of recommendations throughout this presentation, and it's only human to, like if you've seen a list of mitigations, we tend to pick the ones that are easiest, not the ones that are most effective. I think this has been on special display in a lot of ways with the quarantines. Like the easy thing to do is like, oh yeah, wash your hands more. The hard thing to do is don't leave your house. But the effectiveness of those are significantly different. So finally, as promised, in the last 10 minutes here, we're going to get through the good stuff. So tools that are available to automate security, so we just don't have to worry about these problems. And forever and always, we have a more robust and more secure Flask application. So there are many different kinds of tools that we can use. We're only going to talk about two, but just to give them a shout out, there's formal methods, which is like the extreme mathematical end of this. At the opposite end, there's basically do nothing and let people poke at it, which is the intuition behind the bug bounty, where you basically pay people who have found vulnerabilities. And there's things like dynamic analysis, like fuzzing. But what we're going to talk about are secure by design languages and frameworks, as well as static analysis tools for Python. So Google has a book called the SRE book. They just published a new volume of it. And they talk in this book a lot about, hey, here's how we fix security issues at Google. Their preferred way to do it is with frameworks. Because if you fix an issue at the framework level, all of the applications that are using that framework are now suddenly secure in a new way. So in fact, like the example that I gave you, my recommendation number 3 for SQL injection is exactly what Google does when it comes to preventing SQL injection. So what makes some frameworks better than others? Coming back to our Flask, like if you run a Flask app with the debug equals true flag, you'll get a message that says, hey, don't use this in a production environment. This is intended only for debugging use. But really, it would be better if that message said something like, don't use this in a production environment or you'll get hacked. And the best thing you could do would be to say, hey, this is production ready by default, but you're running with some flag that you had to pass that said -- dangerously allow arbitrary code from users because debug mode. So we're letting you do something scary, but we're not going to let you forget about it. We're going to complain about this a lot because you should not be doing this in production. So, coming back to even more concrete examples, again, render template string versus render template in Flask. Pop quiz, which was the one that I told you not to use that was vulnerable? It's not obvious from looking at the function name. So one of the things that I really liked about the React framework was that they renamed the functions that were actually causing injection issues to actually have dangerous in the name. So if you've ever used jQuery, jQuery has an inner HTML, which is an easy way to get hacked through a cross-site scripting thing. In React, that function is called dangerously set inner HTML, which is awesome because now, if you're using that function, you're kind of thinking to yourself, what's dangerous about this? So I would highly recommend checking out this Google book. You can actually download the PDF. It's free. And it turns out they actually have, this OWASP top 10 that I talked about. They actually, for each of the OWASP top 10, have a recommendation about a framework hardening measure that you can use to reduce the risk. So let's talk specifically about frameworks for Flask. We talked about using an object relational mapper. I would highly recommend SQL Alchemy. Actually, if you go to our blog, blog.r2c.dev, we just published a post with Jacob Kapelmoss, I think I mentioned this earlier, the Django creator, about essentially what are the sharp edges. One of the things it covers is SQL Alchemy isn't quite foolproof. So what are the sharp edges that you can still get stung by if you're using that? But in general, you're going to massively do yourself a favor by just not writing raw SQL. For XSS, we talked about React.js from Facebook, but you can combine that with Flask Talisman, the Google framework. You would be in great shape if you did that. And then for XML vulnerabilities, if you're using XML, you should definitely check out if your XML is coming from any kind of untrusted source, this diffused XML library. We didn't have time to talk too much about cross-site request forgery, but there's an alternative to cookies called JWT, JSON Web Tokens, which can help avoid a lot of the cookie stealing attacks that people have had in the past. So another specific shout out, what does Flask Talisman do for you? It automatically turns on HTTPS. It enables strict transport security. It adds some hardening flags to your section cookies. It enables the content security policy. This is great. You should go check it out. And now we get to the last bit of the presentation, which is security static analysis tools. So grep is actually the first thing on this list. This might sound crazy to you, but we see a lot of teams that are basically saying, excuse me, my throat is itchy. Teams that are saying, oh, we should just find this bad function or like this bad pattern in our code base using grep because it's something that's specific to our application. And we don't want to have to buy some like giant expensive static analysis tool to do that. So the best known tool is Bandit. The author of that is actually a friend of mine. It has about 64 security rules, but those rules are not specific to Flask. I think it only has like 2 that are specific to Flask. Same with DLint. These are kind of Python-wide tools. Same with Flake8, which is a more general purpose linting framework. It has some plugins that are more security-centric. But none of these are really specialized on Flask. So that's part of why we made an open source semgrep. So I can just show you real quick. This has a bunch of tools. Here's the GitHub repo where this thing lives. If you just go to simgrep.dev, and then if you pop over to simgrep.live, which is linked from there, there's a whole registry, which is just patterns that we and other people from the community have created. So here's a bunch of the ones for Flask, for instance, like things like deprecated APIs, the render template string that I mentioned has a whole bunch of patterns, and there's specific examples for that you can use. And there's some details about how you can set that up in CI if you want to use it like a GitHub app or a GitHub action to get it set up in your CI flow. And then, of course, there are a good number of proprietary tools. So SonarPython, again, this is this is Python generic, not necessarily specific to Flask or Django. And then there are other commercial tools like Coverity, Fortify, Veracode checkmarks. I don't see a lot of teams using these because they're really designed more for massive code bases. And they were originally developed for C and C++, so I think the Python support was kind of an afterthought. But whatever you do with a security static analysis tool, I would highly recommend setting it up into some sort of flow that looks like this. So do your checking ideally as early as possible, like have it set up as a commit hook so that when somebody types git commit, this tool just runs automatically. Or when they push a pull request, this tool just runs automatically there as well. The earlier you can get this into the developer flow, the less obnoxious it's going to be to have to go back and say, oh, are we using that render template or render template string thing? Versus just telling somebody as soon as possible, as early as possible when they're writing the code, oh, hey, FYI, you may not know this, this is actually a security risk. So the takeaways, read the docs for your framework and stay up to date. I've linked to the security docs for Flask. We cut some snippets out of those. That's a couple times in the presentation. Try to favor secure by default frameworks and architectures, and then set up something to check your code with code using existing toolkits or some custom static analysis tools. And then the last bit here is I would absolutely love your feedback on this presentation. So there's a survey link here that you can fill out. It's super fast, but it would help me become a better presenter if you would do that. So thank you so much for your time. And if there are questions, I can do those now. Let's see, I see there's something that's using the Q&A feature.
Well, thank you. Thank you very much, Isaac. That was really, really cool. Thank you. I can see there's nothing on Twitch. We're clear on Twitch, but I can see there's one question here from Motasin. Can you see that on the Q&A?
I think I have to, okay, yes. Once I've stopped the share, I can see it. So the question is, how does Django compare, in my opinion, in terms of security? They provide a lot of automated security checks. Are they enough to make it secure? Well, unfortunately, Django is actually using a lot of the same, sort of tools underneath. Like Django also uses SQL Alchemy. Django uses a variant of the templating language called the Django templating language, which still has like a good number of gotchas. So I would basically say I think they're about the same, unfortunately. Like the good news is, well, yeah, I would say it's about the same, to be honest. Like I think, people who are writing Flask apps, the Flask stuff, they tend to be smaller applications in general. So you don't often see as many security vulnerabilities. But because under the scenes, they're using the same libraries for SQL or similar libraries for templating, a lot of these issues still apply.
Cool. Yeah, I had the question I had was kind of related to that as well. Like I was gonna ask you how that relates to backend, like to servers. If let's say we have a company that is gonna put a web server, is gonna launch a web server online. Would those measures be enough, or would we have to be doing a little bit more security on the backend as well?
So what could you repeat the question?
Yes. So would those measures be enough on the front end? Would be enough to just secure the application, or would have to do a back end as well?
Yeah, unfortunately, it's not, you can't really isolate to the front end or the back end the security issues. Like you can have security issues just in the way that you did your JavaScript on the front end. It's called like reflected XSS. And then, we talked about a bunch of the issues that can happen on the back end as well. So, I wish it was better news, but there are a lot of tools that have been created to, I think, help the situation. Yeah.
Perfect.
Well, thank you so much for your hospitality and letting me present. It was a pleasure. I hope to meet many of you in person at some point.
Well, absolutely. You're more than welcome to come and join us when you're in Dublin. Please just let us know. Thank you very much. That was very, very good. I learned a lot about security. Thank you.
Absolutely, my pleasure.
Perfect. So, well, first of all, please do reply to Isaac's survey. Just take 2 minutes and then and fill in the form, and you receive the rule package for free. So yeah, it's a treat. Well, I guess we should take maybe some 5 minutes, like a quick toilet break then. We'll be back at 8:07, if that's okay for you guys, with Stephen Finucane with some DRF, some OpenAPI stuff. Thank you. Be back in a few minutes, guys. Perfect. So Maria, here we go. So that's the link for the survey, to reply to the survey. And then the links for the link for the presentation is here. But this will also be at YouTube, our YouTube page. We're banned for 7 days for live streaming, but we're not banned from uploading videos. So we will, true, I'm sorry. I uploaded on the wrong place. I'm sorry. Here we go. Perfect. And then the presentation is over here. Perfect. So we will upload the link for the slides on the YouTube channel. Perfect. Perfect. So we have Stephen just finishing up the setup for his presentation. We'll be back in a few minutes then. Thank you.
Can you see and hear that okay? Oh, hear me okay? I can't hear you.
Yes, you couldn't. I'm sorry about that. How are you, Stephen? Welcome.
Well, good. Thanks for having me. It's going to be a tough act to follow up, but I'll try.
Sorry, you'll be talking to what? Sorry?
I said that will be a tough act to follow up, but I'm going to try.
It was really good, wasn't it?
Yep.
What was your favorite part?
probably the template injection side of things. I didn't even know that was a concern, to be honest. I knew about cross-site scripting and CSI, whatever that kind of thing, because Django forces that down your throat. But
cool. So yeah, I was hoping to see your Greek 10 today. No, it's not going to happen.
sure, let's hope that Firefox does not crash. There we go.
Well, if it's too much for you, it's all right.
Yeah.
So sorry for a little bit of background history for everyone that doesn't know. So Stephen, we're setting up. We're both in Dublin. You're in Dublin, right?
No, Limerick actually.
Oh, you're in Limerick. Okay, so I'm in Dublin. Yeah. Anyway, but Ireland has been having this amazing weather ever since we started the lockdown. So Stephen was telling me how he's looking like a Greek person now. He's cultivating this Greek 10 on the last few days due to that. Yes, exactly. It's Corona weather. Exactly. So that's what the background joke is coming from.
So I'm good to go whenever suits you.
Perfect. So we're back. We're good to start then. So wonderful. So welcome, Stephen. Would you like me to introduce you, or are you all right doing that by yourself?
I can do that myself. That's fine.
Okay, perfect. So stage is yours then. Welcome.
Cool. Okay, so good to be here. I'll get to introducing myself in just a moment, but firstly, what I want to talk to you about today is a documentation-driven approach to API development, specifically using Django REST Framework and OpenAPI. So the previous talk was probably a good introduction to this from the security side of things. This is going to focus more on the kind of side of developing web applications. So about me, I'm normally based in Limerick, but I'm not in Limerick at the moment. I'm back in West Clare at my parents for the foreseeable future. In Limerick, I'm working remotely for a company called Red Hat. Most of you, if you've worked with Linux before, have probably heard of them through RHEL or Red Hat Enterprise Linux. That's probably what they're most famous for, but they're involved in a lot of other communities and a lot of other open source projects. Almost everything they do is open source or becomes open sourced if they acquire companies and stuff. At Red Hat, I've been working on OpenStack, and I've been working on that since about 2015. Again, for anyone that isn't familiar with OpenStack, it's a cloud operating system, if you will, and it's entirely developed in Python. And as a result of that, I've been involved in a lot of different Python projects. So Isaac mentioned a tool called Bandit in his presentation. That's a tool that came out of the OpenStack community initially and is still since migrated to, I think, the Python Code Quality Authority or someone. And yeah, like I said, I've been working on a lot of Python projects through OpenStack and then personal interest and stuff as well. So today I want to focus on Django REST Framework and OpenAPI. So I'm going to quickly introduce what those things are, and then I'm going to go into a bit of detail about why you want to think about Django REST Framework and OpenAPI and how the two of them can combine to great effect. So we'll start off with Django REST Framework. For anyone that hasn't worked with Django or Django REST Framework before, thinking about Django first, it's a very high level Python web framework. It's a lot higher level than Flask would be, for example. It provides a lot more stuff out of the box. And the whole idea is to kind of help you get a web application up and running as fast as possible. So this will provide things like a norm, object relational mapper. It'll provide serializers, web templating, all that kind of good stuff. I think the thing that kind of got it famous the first day was this admin view that it provides by default, where it'll provide a CRUD style web interface for any model that you define in your application. but it's obviously expanded and grown massively since then. A huge advantage that I've noticed in Django over a lot of the other frameworks you'll see in Python and other languages is just the quality of the documentation. So Isaac mentioned a guy, Jacob Kaplan-Moss, before. His blog is well worth a read if you're a technical writer or kind of interested in documentation, about how the Django documentation is actually structured. It's mega impressive. And then the other side of this is Django REST Framework. This is something that builds on top of Django, and it provides stuff that Django doesn't provide out of the box. It's was initially written by a guy called Tom Christie, who gave a talk at FASM this year, actually, that I was lucky enough to be at on a different tool. But it provides a whole load of more RESTfully styled things that it doesn't provide by default. So serialization, so JSON, XML, whatever other kind of serialization you might want. Again, massive documentation, really good quality documentation, and a great community around it. Stack Overflow is just full of questions and answers on Django REST frameworks. So they both come with really good credentials. And if you were to actually go and look at how these would kind of be implemented from a code side of things, Django provides quick start tools that will let you deploy a very basic project or application out of the box. So when you go and install Django from pip or your like distro's package manager, if you're on Linux, it'll install this Django admin command. You kick that off, you start your project, and it'll just dump a whole load of sample files into your chosen directory, which means that you can go and get your application started really quickly. One interesting thing that Django has that I'm not sure carries over to Flask is it has kind of two top level components. It has projects and it has applications. So Django encourages you to develop reusable applications. So the idea that you can kind of take some components of your web application and reuse it in a different web application. So if you go through the Django docs, they'll give trivial examples like polls, for example. They'll give you a component that allows you to generate a poll and will include templates and stuff. And you can go and take that and put it into a website dedicated to news, and you could also give it to a website dedicated to ranking sports stars, pretty much anything you want. Reusability is kind of crucial for that, and Django REST Framework is an example of one such application. So if we take a look at what Django is providing and then what Django REST Framework layers on top of that in more concrete terms. So this is an example of a model using Django's ORM. So the object relationship mapper that Django provides is probably it's definitely not as powerful as SQL Alchemy, which Isaac mentioned in the previous talk, but it is a little bit easier to get started with. This is a very simple model for a post, like something that you see on a blog or something along those lines. Typically, you're going to develop something a lot more powerful than this, but in this case, we have a simple title, date, the author, and then the body of the actual post that you might encourage people to provide markdown or something and render it later. How would you go about exposing this via a REST API? So you could go and write a whole load of views for Django that will generate JSON or XML responses for you, but you then have to go and write stuff like pagination and stuff. You have to worry about that authentication, especially if you're doing things like you're not using cookies, you're using tokens for your authentication. You have to go and write all that stuff from scratch, or you can go use Django REST Framework to do that for you. And that will provide things out of the box, like, for example, serializers. So if I want to go and write a serializer for that post model that I provided, it's something as simple as that. I've actually had to provide a user serializer as well, because the user is a nested has a relationship from the post. And we'll see in a moment what that'll actually look like from an end user perspective. But as you can see, it's pretty trivial to get started with. And another really nice, powerful thing about this is it's easy. You can do very simple stuff if you want, but then you can add on additional complexity as you need to. So this is all auto-generated based on introspection of the models. But if you decide that, for example, you wanted, if you go and render this, you'll see that the author field in the post serializer will just be a URL. If you decide that you wanted to actually embed the user inside there, so like a minimal version representation of the user, Django REST Framework obviously provides the ability to do that. You take those serializers then and you wrap them up in views. This is kind of this is Django terminology that probably carries across to a couple of other frameworks. But the way that DRF does this is you provide your query set, you say what your serializer should be, and then what kind of permissions you want to have on that. So there's two examples of permissions that I've used here. The first is the post view set. So I said that anyone that wants to explore this via the API, they can read it if they're not authenticated, but if they're authenticated, then they have write permissions as well. Realistically, you wouldn't actually use something like this in practice, because you don't want anyone that's logged into your website to be able to edit any post. You'd have far more fine-grained objects, but as a cursory introduction to it, it's pretty good. And then the other one is authenticated, which, as you'd suspect, just checks that you're authenticated and doesn't allow you to access the resource. And again, all of this stuff is provided out of the box. And then if you wanted to go and render this, you'd have to provide what Django calls view or URLs, like the urls.py file. Something unusual about Django REST Framework, if you haven't used it before but you have used Django, is that it includes this idea of a router where it will automatically generate your URLs for you. How that actually looks when you try to kick off your server is you run your server in the background and you make a request to the server. And because I hadn't actually created any posts, I get an empty response. But we already see some of the stuff that Django REST Framework is providing for us, so it does all the pagination stuff automatically. Most of those should be self-explanatory, but a link to the next page, a link to the previous page, and then some results. If I go and create an example of a post, which I just did via the web interface, which I'll show in a moment, rather than curl, because curl is quite arcane, the incantations to get it going. We'll see an example of one such response here. Another thing then that it provides on top of that is what I just mentioned, the browsable web interface. So if you go to your API URL in your web browser, you'll see something along the lines of this. And even though it's not actually in scope there, if you scroll down further down the page, you'll see a nice, pretty HTML form that allows you to create stuff on the fly via the web interface, as opposed to having to kick into requests or down into a shell or something to do that. So I mentioned at the top that I wanted to go and look into explore documentation as one of the things that OpenAPI gives you. Before we look at that, it's worth noting that Django REST Framework provides some level of documentation out of the box. So if you make an options HTTP request, you'll get a response back that gives you details about all the different fields and stuff in the response. But it's pretty cursory, more of a summary thing, and you can get a lot more detail, as we're going to see. So OpenAPI is nothing specific to Python. It's this huge, massive spec. I think it's about 150 pages, the actual spec of verbose, almost legalese language. But the basic idea behind it is to provide a language agnostic way of describing RESTful APIs. And that description that you provide should be both human and machine readable. And if you had a complete implementation of such as like spec schema using OpenAPI, you should be able to understand and interact with that API programmatically. So as we'll see, that will mean you can do things like validating your API against a specification, generating clients from that specification. In fact, you can actually generate servers from that specification, although we're not going to go into the last two here today because that's talk in its own way. But what do those look like? So OpenAPI can be YAML or JSON formatted. Personally, I'd recommend YAML if you actually want to be able to read this thing. They don't support an XML style schema, thankfully. But it's this quite verbose, again, language where it's all broken into different stanzas. YAML provides a lot of power in terms of cross-referencing. So you have the ability to break a sample schema into multiple different documents and cross-reference back. But as a very minimal example, this is taken from the OpenAPI website that shows a user's response that is simply an array with a list of user strings. So how does that tie back into Django REST Framework? So it turns out the Django REST Framework provides the ability to actually generate these schemas from scratch yourself. So based on your serializers and your models. So if I was to generate that on the serializers that I demonstrated earlier, it'll generate this, I think about 200 or 300 line long schema. It's quite incomplete, and this isn't something that you'd be able to generate a client from because it's just missing too much information. But it provides a good starting point for documentation, as we're going to see. And it also provides a good starting point to go and hand edit yourself and expand to generate something more complete. So from the if you were to take that and use it in its raw form or to modify it to get what you wanted, DRF provides the ability to generate views or URLs out of the box that will take that schema and render it in a much prettier manner than that ugly YAML file that you saw. So the first one of those is this really cool JSON or JavaScript tool called OpenAPI schema. So I give an example there of a URL that linked back to that would serve your OpenAPI schema at a given URL, and then a different one that would render this JavaScript page reference back to the OpenAPI schema and then give you this pretty output. Again, you can modify this so that it's read and writable, but even in its read-only form, it'll give you a much prettier representation of your API that your consumers can go and interact with. And then there's a whole load of other tools existing in the Python ecosystem that you can go and use to provide documentation if you don't want to use some JavaScript tool. So the first one of those, for anyone that hasn't used the Sphinx documentation tool, that's widespread across the Python ecosystem. There's an OpenAPI extension for that allows you to use this directive within your restructured text documents in Sphinx. And if you go and you render that, it'll give you this very nice output. That not quite as pretty as the JavaScript thing, but it's integrated into your documentation. So you have documentation that provides a very high level overview of your application. and then you want to give an actual inline API reference, you can use this Sphinx contrib OpenAPI package to do that for. And then there's also a redoc package. This one isn't quite as well integrated. It doesn't really tie into the rendered Sphinx styles and stuff, but it's pretty easy to enable, and it looks quite similar to that OpenAPI tool that I showed earlier. Again, this can be read and writable. So you've got documentation, but another really useful reason to have an OpenAPI schema, generated or handwritten, is the ability to validate that OpenAPI, validate the server or validate the client. So OpenAPI spec validator, there's a whole load of these different tools available. This is a Python implementation of an OpenAPI spec validator. So you can use this from the command line with an existing YAML or JSON file to make sure that it actually is compliant with that massive 150-page document that they expect people to read on OpenAPI. But you can also go and integrate that into your test suite. So Django obviously provides good testing capabilities, but you could do this with or without Django. You take a schema, you load it up, and you pass it into this library, and it'll tell you yes or no, is the schema that you're after writing or auto-generating from DRF actually valid? And well, that'll tell you it obviously is. But on top of that, you can get into things like actually validating the requests and the responses that you're sending to the server. So this is another related tool, OpenAPI Core, that provides a whole load of wrappers around things like Django and requests, as we'll see in a moment, where you can kick off your Django server application. You can make a sample request to that, and then you pass that request and the response you get back from the server into this library, and it will go and compare that against the spec that you have and tell you whether your spec is complete or whether your spec is compliant to the server or vice versa. And that's the server side of things, because I'm assuming anyone that's working on servers is also providing a client for their end user. If you're using something like requests, you can go and wrap that up nicely, feed it into that OpenAPI core tool, and generate a summary of whether the spec is compliant or the request that you're making to against the spec is compliant. So that's a very high-level overview. And to summarize that, Django REST Framework is awesome, and I'd highly recommend people try it and get going with, get started with it. It provides a whole load more than you would get with Flask. In some cases, that means it's going to, you might feel like it's holding your hand a little too much. But personally, for a quick demo project that's actually something usable, it is a good place to start with. From an OpenAPI schema perspective, a good technique to approaching these is take the thing that Django REST Framework generates, and then start hacking on that to fill in the gaps. Because as I said, it isn't a complete representation, and it also falls down on things that are a little more dynamic than you'd expect, so generated fields in your responses and so forth. Those schemas can then be used in documentation, either with Sphinx-based tools or with completely independent tools, nothing to do with Python. And then you can also use those schemas to validate both your server and any clients that you decide to write. A few other things that you might want to look into doing that I didn't cover here today because I wanted to keep this fairly high level. You could transparently validate requests and responses within, for example, your test framework. So intercept the sample request that your test framework is making against your Django server, and make sure that each of those is compliant. You can also look into order generating APIs. So there's a Java-based tool, the OpenAPI or Swagger generator, that will allow you to generate Python clients, Bash clients, pretty much any language you can imagine for your given schema. And then actual auto generation of your APIs. Once you have a schema, you might even decide that you don't actually want Django REST Framework anymore. You want to go and write something with Node.js or something. There's a whole load of frameworks that exist in Python and in other languages that let you take a schema and provide a very basic web interface that you then have to do just provide all the database and or modeling behind the scenes. And that, in a nutshell, is how you might get started with a documentation-driven approach to API development with DRF and OpenAPI.
Cool. Thank you very much, Stephen. That was awesome. Thank you. Perfect. So anyone would have any questions? Let's wait a bit and see if we got any questions for you in the chat. I know someone that was very, very excited about your talk. Let me see. Yeah, no, it doesn't seem like we have anything else. Well, but thank you very much, Stephen. It was an honor to have you here. Thank you. And
thank you.
I hope to see you soon. I hope we get to see each other again at PyCon this year. Perfect. Wonderful. So we don't actually have any questions anymore. And we also don't have, we do have a question. Stephen, come back.
I'm still here.
Sorry. Perfect. So Adia is asking if OpenAPI is suitable for Django and Flask as well.
Yeah, OpenAPI is nothing to do with Python. It's just it's one of the many competing options for documenting your API, your RESTful API. But it's probably at risk of sounding biased, it's probably the leading one at this point. So it was donated to a foundation by to a company called Black Bear or something. It was previously called Swagger, and since then it's gone through, it's moved to version 3.0, and then there's multiple patch versions of it. And as I mentioned, there's nothing to do with Django, so you can use Django, you could go and use Flask, you could use some JavaScript framework, you can use pretty much anything you want. But yeah, nothing to do with Django. It just happens to tie in quite nicely to Django REST Framework.
Perfect. Thank you very much. Thank you. So yes, I don't think we have anything further for tonight. Perfect. Yes, I think that answered her question. Thank you. Wonderful. So I'm gonna call it quits here then. Thank you very much for the panelists. Thank you, Isaac. Thank you, Stephen. It was a pleasure to have you here with us tonight. And I will see you guys on the 27th then with a lovely workshop on deploying a chatbot on your CLI. I'm very excited about that. I hope you guys get to join us as well. Well, thank you, Stephen and Isaac, for the nice talks. And well, thank you, Matasin. We're getting some comments on the chat now. Thank you, guys. Thank you. Bye-bye. So stay safe, and hopefully we get through this soon. Thank you. It was a pleasure.